This demonstration is one of the final projects for the Siemens safety applications in process automation. So there are many options to use in the Siemens portfolio, Siemens safety portfolio. There are many options, and in this example, we use safety matrix. The application is a distillation tower, and we want to protect the uh, distillation tower against overpressure. Uh, as you may remember, we previously demonstrated the control of distillation tower by using strong templates, control templates of PCS7. Previously, we did it in our PCS7 course. Now, in this safety course, we try to monitor the pressure of the column. The pressure of the column is monitored by 3 transmitters, and the steam valves, the steam um, flow of steam can be shut down if we encounter overpressure. We use 2 out of 3 for this example. We use 2 out of 3 in order to uh, shut down the supply of steam to the column. So if we have the overpressure here, so one reason for overpressure is high temperature here, high temperature, because the inlet for distillation tower is crude oil, and crude oil by helping this exchanger here, we try to convert crude oil to other components, and in case of excessive temperature here, the excessive temperature will increase the buildup gas at the top of the column. We measure the pressure at the top of column by using 3 transmitters, and these 3 transmitters will be will play important role to shut down the supply of steam, and it's somehow a shutdown of the column. So let us. So when we restart the CPU, we decided that these valves shouldn't operate automatically in case of a power cycle. We decided operator acknowledgement to energize those valves, and the control is performing like before. So in this slide, consider we are the time after power cycle, and the operator need to acknowledge by using possibly a safety digital input. So you can see that in this slide, acknowledgement is done. Acknowledgement by operation team is done, and valves are open, and it's possible to operate the distillation tower. You can see that the pressure limits are okay here. They are within the normal range, and we try to simulate by applying some values to to show that there is a overpressure. So for one transmitter in this slide, for transmitter A, we have overpressure for transmitter A, but you can see that it doesn't meet 2 out of 3. Valves are operating properly. So reading in transmitter A may be a wrong reading, and it's required attention. Possibly the transmitter is faulty, and we need to check and rectify the problem. But the system is working fine. The safety system and the control system is working fine with one violation. But when we have transmitter A and transmitter C, 2 out of 3, transmitters are violating the high safety limit. The steam valve should shut down. The steam valve should shut down. So after a while, everything is getting back to normal. The next slide. Everything is getting back to normal. The pressure, they are getting less than the violation range, but the valves are not operating because we decided based on the safety requirements that in order to energize the valves, we need the operator intervention, and we need to acknowledge the operator has in some cases a physical button on the control room or on the panel in the side, a button on control room, or a physical button, or a button on the HMI to acknowledge the operator should acknowledge that overpressure happened, everything is cleared, transmitters are in normal range, and acknowledge is done. When acknowledge is done, the steam is back to the steam will be back to the steam will be back to the column. So the other rare case it may happen when we have a channel fault, when we have 2 out of 3 channel faults. In this case, transmitter A and transmitter B, they have channel faults, and it will shut down the solenoids or the steam, and you can see that they're red, and commands for the solenoids are getting off, and solenoids will close immediately.